Welcome to 2016 question A-3. So this is a conics question. The 3D graphic below shows a pencil in the form of a rectangular prism. When the conical top is applied to the pencil by the sharpener, the result is a series of hyperbolic curves near the top of the pencil as shown. Okay, so same as the pencil here, we have a cone shape, and then it is a vertical section. If we look at our hexagon, it creates a vertical section which gives us actually a hyperbolic shape. So the drawing on the right shows the axis AA, so here's our axis, here's our directrix DD, and a focal point for that hyperbola. A hyperbola has an eccentricity of 3:2. Locate the position of the vertex and draw a portion of the hyperbola. It is only necessary to draw one branch of the hyperbola, because in reality, hyperbola, there's a double hyperbola here. So, eccentricity, or ECC, is equal to PF over PD, which in this case is 3/2. 3/2. And using measurements that we can actually apply to the drawing, we'll say multiply everything by 2, so 30/20. Okay, so my PD, so my distance from my directrix, point to the directrix and point to the focus, okay, is going to be 20, and my PF is going to be 30. So PD, I'm going to measure out 20 from my directrix, and vertically up then, I'm going to measure up 30. Okay, I could also double everything there. I can go 40 and 60, probably would be a bit more accurate, but that will do. So that is my line of eccentricity. We want to locate the position of the vertex. So, as with all conics, if I go 45 degrees back from my focal point onto my line of eccentricity and drop that down onto my axis, that will find me my vertex V. Okay? Then we want to draw a portion of this hyperbola. I need to draw my latus rectum first of all. And that has actually found me a point on my curve there, because my line of eccentricity is tangential at point F, or at the latus rectum. So next I'm going to pick random points coming out here. You can do set distances if you want. I'll just do random distances. And always do a point between V and F as well. Okay, so where each of these ordinates, or double ordinates, hits my line of eccentricity, I'm going to draw a cross until I hit my vertex. I'll actually do another point here. Okay, so draw a cross until I hit my latus rectum. Okay, and for the point inside it, same thing. We draw a cross until we hit the latus rectum. And I'll just label latus rectum just so you're clear. Okay, so that's that line there. Then, where the point here comes on from the line of eccentricity comes out and hits my latus rectum, I'm going to get the distance from F to that point and rotate it down onto that ordinate that I've drawn, and it's going to be symmetrical on both sides, so I'm going to find that same point down here. I'm going to repeat that for all the points. Rotate that down and find it down here. And finally, it's gone below where I need it to be. And then lastly then, I'll do my point inside the curve, rotate it down, and locate that here. And don't forget, as I said at the start, this is a point where my lattice rectum intersects my line of eccentricity. That is also a point, so I can actually show that down here too. So my curve is going to run through all of these points, tangential to there, down to V, along like that. So drawing my curve, I always want to look at the point that I'm going to. Don't look at the point of the pencil. That will give me a nice gradual curve. Right, so that is part A completed. Locate a point P on the curve which is 60 from F, or from the focus, and construct a tangent to that curve. A tangent on the curve at point P. So first of all, let's locate point P. I'm going to set my compass to a length of 60. 60. And from F, I'm going to swing an arc. I can go top side or bottom side. Okay, that kind of goes outside the question. So I'll use this side here. So this is my point P. Okay, and I want to draw a tangent to that point. Now there's a number of different techniques or methods you can employ here, but I like to use a consistent method that works for all conics, eos, parabola, hyperbola. So I'm going to join P to F. Just highlight this so you can see it. Okay, and if I go 90 degrees from or to that line back from F until I hit my directrix, so highlight that. That's a 90-degree angle. Okay, if I join where it hits the directrix back to point P, okay, that will be a tangent. Highlight that in there as well, just to show you. Okay, so here we have a tangent. Okay, and as I said, that construction works for all conics, but there's a couple of other methods that you can employ there. Use whichever one you know. So that's 2016 A3 in my conics question.